Fantastic. Welcome, everybody, and thanks for joining today. As we advertised, we've been experimenting for the last few months on combining CUE and Terraform, and today's session is really designed to dig into a bit of details of what we've been experimenting with. The title is slightly misleading in that it says CUE plus Terraform, but actually there's a bit more detail behind that. Jonathan, if you don't mind the next slide, thank you. Because what we've been using is CUE and Terraform to drive our GitHub configuration, specifically our configuration of organizations and repositories, but it's not limited to that. That's just what our experiment has been touching on. The next slide, please, Jonathan. So let's just look at the agenda. First of all, we're going to motivate why we've been doing this experiment over the last few months, then dig into the details of what exactly is this experiment. Then the most exciting bit being the demo. Let's hope the demo gods are with us today, and leaving plenty of time, hopefully, for a Q&A at the end. Very briefly on me, my name's Paul Jolly. I work full-time on the CUE project. I've previously contributed a lot to the Go project, especially on the tooling side of things. And so my interest really on the Terraform side of things really fits into that bucket of tooling and things I wish I was better at. I'll let Jonathan introduce himself, and we'll also motivate why we needed someone like Jonathan working on this who has the Terraform and ops infrastructure experience.
Hey folks, I'm Jonathan Matthews. I'm a technical operations specialist, which, like we were all alluding to before the call, started being recorded. It's a title that I think reflects the past 20 years of my career, from being a sysadmin, working at ISPs, being an applications hosting expert, focusing more and more on cloud, because working inside data centers sucks. Being a DevOps, being an SRE, whatever will get called in the future. I run and fix other folks' systems and services, often by gluing together the right choice of technologies. And that's why I really enjoy working with CUE, because it gives me that glue and lets me apply it really elegantly and powerfully. I recently started the open source Cuneiform project, which also sits in this space where CUE and Terraform meet. It's not what we're talking about today, but it's clearly adjacent. You can get hold of me on jonathanmatthews.com. Paul.
Super, thanks. So digging into why we are doing this today, why have we done this experiment? So next slide, please, Jonathan. So as the CUE project, we have a number of GitHub organizations that we manage. Each organization has a number of repositories within it. So there are some rough numbers attached to it there. This changes quite frequently with the number of repositories obviously going up. Within those organizations, I'm teaching a number of folks, if not everyone on this call, slightly information they already know. We're managing things like the visibility of repositories, access control, perhaps webhook configurations, branch protection rules, whether issues, discussions, wikis are on or off, what tags exist for labeling issues or discussions, maybe even GitHub Actions configurations as well. And so managing all of this actually takes quite a bit of effort. So how are we actually doing that today? Well, unfortunately, prior to this experiment, we were doing most, if not all of this, via the GitHub UI, which has a number of drawbacks. And let's just talk about some of those. There's no concept of code review on a change when we're doing anything via the UI. Errors are more likely on the basis that we are all human and everyone makes mistakes every now and then. We manually need to coordinate as to who is making what change. We have no way of viewing the entire configuration of all of our organization repositories at a glance. And we have absolutely no concept within this of being able to apply any concept of policy, template, or reuse. Now, if we think about all of these things here, sorry, Jonathan, just back one slide, 1 second. All of these things feel like things that are problematic in some way, shape, or form. And even for a project the size of CUE, and we are by no means large in terms of our large use of GitHub, it's problematic that we're having to do these things manually in any way, shape, or form. So doing it in a different way, well, GitHub has an API. Why would we not use that? It has an imperative API to mutate the configuration state. So we need to tell GitHub what to do in order to change its configuration on a repository and organization, for example. But it doesn't have a way of accepting a declarative statement of what an organization, repository, etc., how those things should be configured. And ideally, if we return to the point on the previous slide, it would be really nice if actually we could just say, for all these things here, please configure them as such and give it a big blob of configuration and for GitHub to do just that, to make that happen. No such API exists. So in lieu of that, what we're missing is some sort of executor that transforms a declarative representation of configuration into something that mutates the current configuration state of organizations or repositories in GitHub. Next slide, please. So this was a question I posed on Twitter, because that's really the best way that I know of trying to get answers to these questions from folks out there. How do folks actually manage this? And I haven't yet. If somebody has a better answer to the answers that we've received, would love to know it. How do folks in large organizations actually take what is a declarative configuration and apply it to organizations and repositories in the wild? As I said, all the things that we wanted to cover earlier on, organization members to repository visibility settings, everything that is essentially configurable under an organization repository. We had a couple of responses back on the next slide. That Terraform is a good place to start with this. So that's exactly where our experiment started, in terms of saying, fine, we're unhappy with clicking around in a UI. We don't feel that's robust enough. Let's explore what Terraform might look like. So I'll just hand over to Jonathan now to kick us off on that side.
So what exactly is this experiment? Well, before we can step into sort of where we've ended up, let's quickly run through our options. Option 1, the traditional HCL. Big blob of HCL. It is declarative, so it is reviewable, it is auditable. You can look at it and see what your state should be, but it's straining at the edges of what we could call structured data. It is technically structured data, but it gets unwieldy over time as a system evolves. How about CSV-driven HCL? Structured data driving our HCL. Now that's closer to what we like. But more complex runtime logic ends up inside the HCL in order to wrangle the CSV into the structures that HCL requires. From personal experience, I know that doing this means your organization is making a bit of a bet on having folks around who can understand pretty advanced HCL runtime expressions and logic, not just to extract from the CSV, but to mutate it into the shape that best suits HCL's requirements. What about using HCL variables or locals, actual structured data expressed as HCL, to be interrogated by other HCL elements, which then create our Terraform resources? Well, that could be much closer to the situation we'd like to end up with, but significant HCL complexity is still required in the config. Terraform also still needs to work out what resources exist in the config graph at runtime, which isn't a showstopper of a problem, but it lacks a couple of really nice properties of the system that we're about to show you. That first property of our system is that all the resources that Terraform is being asked to create are tangibly visible, sitting there in front of us in our config. We can be confident that so long as Terraform internally does the right thing when asked to create a repository called foo, we'll end up with a repository called foo. If Terraform is also in charge of figuring out at runtime that such a repo even needs to exist, and then figuring out the repo's config, then not only do we have to trust Terraform to do both of those things correctly, we also have to trust ourselves not to get things wrong in multiple different code paths and files. The second property, nice property of the system, is one we'll come to in a moment. But there's another way that Terraform can be configured, in JSON, effectively with structured data. And there's a JSON form of Terraform's HCL language that Terraform also understands, which is nice because CUE, the core focus of the CUE project, knows a fair bit about managing JSON sustainably at scale and generating JSON and YAML for tools that don't yet understand CUE. So it was quite a natural progression for us to think in terms of the CUE features that we could draw on. As you'll see, some of those features are CUE templates, CUE defaults, and CUE policy assertions. Other approaches exist to configure Terraform via JSON and dried out HCL, such as CDK-TF and TerraGrunt. But this is an experiment looking at what working in this space feels like in CUE. Shortly after this session, we'll be publishing a publicly available version of this experiment's code on GitHub. It's definitely a first cut of the system that specifically targets the CUE project's aims. You are extremely welcome to check it out, adapt it, use any of it. Do please read the docs before deploying it, however, as the CUE project's assumptions and objectives might not match yours, and you might just need to adapt it first. So CUE generates JSON. JSON configures Terraform, Terraform drives GitHub. CUE also configures and drives GitHub Actions, which is the execution environment in which we invoke Terraform. And that's the second of the really nice properties of our system. The data sitting at its core, configuring our GitHub resources in Terraform, can be used to emit configurations for as many other systems as we need. It can act as our single point of truth. This is a property which, being pretty fair to HCL, simply isn't the case if we store data inside HCL, even nicely structured. HCL is relatively poor at interoperability outside the HashiCorp ecosystem. Today, we're not going to focus on the GitHub Actions jobs or the code that glues them together, except to note that they're configured from the same core data as Terraform, which implicitly keeps both systems in sync. Okay, enough talk, more showing. Time for a demo. Okay, folks do shout out if that's not coming through loud and clear. I hope it should be. Here's my terminal. Editor at the top.
It's all good.
At the bottom. Thank you. The system is already managing 2 GitHub orgs, nicely named by GitHub for us: Fictional Meme and Supreme Octo Enigma. All the config that we manage lives inside this config directory. It's a single CUE package spread across an arbitrary set of files that's unified by CUE to produce our config graph. Both orgs' config files are empty, which means that they contain the set of resources and settings that the system defaults to. You'll see more of that later. Let's start by creating a repo. Let's choose the name randomly.
So just to clarify, with the empty file you see at the top there, empty in quotes, for the fictional meme organization, that implies that there are no repositories that are part of it as well, correct?
Absolutely correct.
Yep.
Let's choose a random name. Let's go for Stoff. Stoff looks like a winner to me. Let's tell CUE that we're managing resources and we're managing GitHub repository resources. This repo is called Stoff. I do hope that's not a rude word in some non-English language. Apologies if it is. And it is a public repo. Okay, that's it. That's all we need to configure in order to get Terraform to create this repo. Now we need to turn this CUE into Terraform's JSON input. And we do this via the make generate recipe. This runs a few commands, including testing that our unified configuration is consistent and valid. And it also generates input files for both Terraform and GitHub Actions. Let's see what came out of this process. Okay, well, first we have our config changes, as expected. That's what we put in. But we also have changes inside the operations directory. This is where our generated Terraform config is placed, and we can see more changes here. Starting at the bottom of the file, we can see the repo itself being created with a few more fields that CUE has injected for us. Back at the top of the file, we can see access being granted to this repo for the employees team. More on that later. Let's commit these changes and push them up to a branch. This repo lives on GitHub, so let's open a PR to merge these changes into main.
Just to complete that, just to take us back to the image that Jonathan showed earlier on, this is where the GitHub Actions piece now comes in. This is the thing that's driving Terraform in this situation.
Absolutely. So let's open a PR and kick off those GitHub Actions. We might normally put more information in here, but just right now. We're just kicking in when getting this going.
Thankfully, we're not reviewing the commit message in this situation.
System tests changes via PRs. We test each org's config, and then we run Terraform plan across each org. And as those Terraform plan invocations complete, their output is posted back to the PR as comments for the author and reviewers. We can see that Terraform is doing what we intended, making no changes to Supreme Octo Enigma, and adding our expected couple of resources, GitHub repository and GitHub repository collaborators, into fictional meme. So let's rebase and merge this PR. Merging the PR into main re-triggers the test cycle, which is important. So we'll get the up-to-date Terraform plan output posted back to the PR. Once that has run through and both tests have passed, we will then be followed getting the output from Terraform apply. Let's give GitHub Actions time to get its shoes and socks on and get going. Here we go. So that's the proposed changes for both org. We see that, as expected, the plan is the same across both. And now we're just waiting for Terraform plan to run in the background.
Terraform apply, I guess, now is the second.
Terraform apply, quite right.
Yep.
Yes. Yeah. There we go. So, unsurprisingly, the organization in which no changes being made was both successful, and it was the fastest to come back to us. Let's head over. There we see fictional meme successful. Let's head over to fictional meme and check what we've got. There we go. The stuff repository created is public, as we'd expect. But it's missing a few features that we might possibly expect. It's missing, for instance, the Issues tab. Now, that's because the CUE project takes the view that features like repo issues should be turned off by default, but can be enabled when needed. And we do this by using CUE to inject these defaults into our config unless they're overridden at the repo level. Let's take a look at that now. Here are the defaults that we've chosen to apply to all repos. This removes any ambiguity of what GitHub's API might default to or what Terraform's GitHub provider will choose to do by default. Let's override the issue setting for our new repo.
It's worth just briefly mentioning there, Jonathan, that if you just go back to the previous buffer, what we're doing there is something that is classically referred to as templating. So as Jonathan said, if you read line 30 there, the way to read that out loud is something like the following. For all organizations that we declare, and for all repositories within all of those organizations, this set of defaults, in this case, should apply. And as Jonathan's about to demonstrate, where you want to vary from that default in some way, i.e. provide a different concrete value, then you actually have to do that at the point of declaring, in this case, the repository.
So let's do that. Let's turn on issues for this repo. So we set up as issues, and we're not going to push each change that we make through a PR during this demo. Just be aware that if we did, we'd see the same kind of output and PR comments that we saw when creating the repo, and we'd follow the same review and rebase and merge process. I'll regenerate the Terraform config. And you might be wondering why I'm generating the config on my developer machine. Surely that's the point of using CI like GitHub Actions to automate as much as possible and to reduce toil. Well, the answer is that both CI and myself are running this critical step. CI tests are checking that our generated configs are identical and that both match the source CUE files. This gives me, the operator, certainty that the config that Terraform will apply is the one that I'll be committing to Git, the actual underlying JSON file. And it gives my organization confidence that our human PR review process is looking out for changes that matter and not wasting time on checking that our source and files and our generated files are in sync. Let's commit the change that adds issues to the repo, but we're not going to apply it directly just yet. So let's add that. And we'll do demo, add issues. Okay, next, let's onboard a new employee. So there's me as the sole employee at the moment. Let's add Alex. Now, Alex has a GitHub login, and that GitHub login is CUE. And let's regenerate our config. Notice we didn't add Alex into any specific org. We added them into a seemingly unrelated struct. And that's because, as we can see in our Git status, this change has affected all our orgs. Alex will be invited into this org as a member and is added into the employees team, and exactly the same in the other org. This process uses, I just made a change, there we go. This change uses CUE templates. It operates across all our orgs. As Paul said, reading it left to right, for each org, if this predicate is true, then add in a GitHub membership correlating to the employee, and it adds a GitHub membership in, and it adds in a GitHub team membership. Let's carry on and pretend that we've made a mistake. Let's pretend that we shouldn't have added Alex as a company employee. They're actually a third party who only needs access to a single repo, to the repo that we just created, in fact. So let's start off by removing them from the employee list. And then let's grant them access to just that single repo. And rather than doing actions inside this repository, we're going to use an abstraction that we've built in CUE. Our abstraction is called non-org member access. This is about collaborators, not bots. That's the other half of this. Their username is CUE. The repo that we're giving them access to, what do we call it? Stop. And what access do they need? They need push access. Okay, let's regenerate our Terraform config. And I'm just going to get that. I'm going to get the previous change out of the way. Let's regenerate and see what the result is. As we can see, as expected, their membership of each org has been removed. And we see them added to the list of users with access to this single repo. Abstractions like this are a really powerful CUE feature, especially when configuring Terraform, because we can build abstractions which let our users add as many different resources and resource types to our config as needed, really easily without having to install Terraform modules or audit third-party code. All right, let's really make a mistake. Let's change Alex's access so that in that single repo, they're now an admin. Let's regenerate our config. And a big explosion occurs. I won't step back through the whole of the error message, but we can see from the last line that there's a problem with the user permissions on the Stoff repo. Let's take a quick look at what's going on behind the scenes. Here, templated in to each and every org and into each and every GitHub repository collaborators struct or resource is a policy constraint. Users can only be granted pull, push, or triage permissions. on a repo. That's what caused the explosion, and it stopped us from generating and committing config that disagrees with this policy. But can't I, as the operator, simply expand this list? Can't I change the policy, regenerate the config, and push the change through a PR? Well, no. This is one of the very few places where the name of the file we're editing is important. It's not important to CUE, which doesn't really care what file names we choose inside a package. No, instead, we're using a GitHub feature, which forces changes to specifically named files to be reviewed by specific people. Here, in the code owners file, we're saying that any changes to star.admin.q files in a PR need to be reviewed by a set of folks with admin oversight. So here, a policy in a star.admin.q file is more than just a nicely formatted comment in a YAML file that's saying we'd like folks to make sure they don't do something. No, combining these two features actually blocks changes that don't obey the policy. That's the end of the demo section for today. There's loads more, both in the system and in CUE, that helps operating Terraform safely. I really hope that you'll check out the repo after we publish it later today and let us know what you think. There's an announcement thread in the main QLang GitHub discussions that will be updated, or if you're watching this recorded after the fact, then it'll be available right now in the CUE examples GitHub org. Paul, back to you.
Thanks, Jonathan. If we've got the remainder of the slides. For folks with questions, I'm almost at the end. So if you can bear with me for 30 more seconds, then we'll be done. So I think an important way to finish the presentation is to ask whether this experiment has been a success or not, because we set out as an experiment, so we need to really answer that question. So has it been a success? Largely, yes. We have this running in production right now, as in we have thrown away our manual maintenance of GitHub organization and repository configuration. And we're driving almost all configuration of values within orgs and repos via this setup here. I have to say the combination of CUE's tooling via things like CUE-FUMPT, CUE-trim, combined with defaults has been an absolute delight, because now we have that ability to see where, for example, there are variations within repositories and actually document them as well. So to take a very, very simple example where we give bots access to certain repositories, we can clearly document in the CUE why we are giving a bot access, what it needs access for. That might seem like a small thing, but that is absolutely not something we've had before, other than perhaps trying to maintain something in a Google Doc file or a wiki alongside the repo itself, trying to explain why we gave a particular bot access to something.
And if I can just back up something you've just said there, Paul, saying that this is the first project which I've really used CUE-trim on when doing refactoring of CUE, and that has been life-changing at the moment that actually happened. Sorry, that sounds like hyperbole. It really has made my operations life better to be able to go CUE, work out what I can throw away, work out what I'm saying in my templates, in my policy, and whatever it happens to be, and just keep the content that I need inside my org level settings. That has been fantastic.
So yeah, we have all the CUE project organizations and by implication all the repositories within them covered, and we've actually stripped back the configuration such that members of organizations cannot now create repositories via the UI. Everything has to happen via our infra repo, as we call it, which is a very nice point of control as well. It doesn't really, it slows down the initial creation of a repository, to be fair, but the maintenance aspect on an ongoing basis is far improved, and there's also control over it as well in terms of what values are being set configuration-wise. Next slide, please, Jonathan. Just briefly on the next steps, Jonathan has talked about it. We're going to publish this experiment. It is an experiment. I cannot stress that enough. It's an experiment that might explode if you try to use it yourself, so please treat it with caution, particularly given that it does involve creation and, if you're not careful, destruction of resources as well. One thing we do want to do is extend our configuration, our internal configuration, to cover all aspects that are configurable via the UI. For example, webhooks, branch protection rules. We also want to explore and kick the tires on how secrets and variables can be injected into that flow as well, because guess what? That is also something that currently has to happen in a manual way via the UI as well. Understand where external secret systems fit into this, and how CUE can work with all those things together as well. For a number of our repositories, we have GitHub as a source of truth. That's just because we prefer to do code review in GitHub. What we also then want to do, as Jonathan was suggesting earlier on, is branch out from just the GitHub organization and repository configuration, plus the workflow configuration, to also include the GitHub configuration in this single source of truth of configuration. So now we logically have one configuration graph for a number of different systems that the CUE project depends on. They all come from a single source of truth, and they are all executed on from that single source of truth as well. So if the executors do their job, we have consistency between all the systems. And whereas previously we had configuration silos, we now logically have one configuration graph. And so that is also something that makes us feel a whole lot better, rather than trying to manually maintain consistency at worst between different configuration in different systems. So I think we're done there, Jonathan, unless there's anything else from your side. I think the last slide should say Q&A, and so at this point we will turn over to those. Tiago, I think you had a question, and anybody else who was patiently waiting.
I'm sorry, I pressed the button by mistake. I do not have a question.
That's no problem at all. David.
Yeah, so with this setup, you're able to drive multiple Terraform state files from a single CUE set of configurations, right?
That's correct, yes.
And then I suppose the layer that orchestrates the ordering of applying those Terraform separate state files would be something you orchestrate different from the CUE code, or is it implicit there?
So at the moment, it's implicit that Terraform state, which we currently have set up as one per org for reasons I can go into if folks want, we have that where there is no cross-org, there are no cross-org dependencies at runtime, or at the very least, none that we can't resolve and give to Terraform to do the right thing through the configuration. Thus, we do them all in parallel. I think that it wouldn't be that difficult to inject into the orchestration layer of the GitHub Actions that chooses what to do in what order. That would not be particularly difficult to build in, but that hasn't been a thing that we've done in the system thus far.
Awesome, thank you.
David, if I could just ask, what's the reason for your question there? Because I think you're hinting at something that is a very interesting area that we haven't had to explore, but could explore.
Yeah, so in large orgs, you don't have a single state file. You end up splitting your state files into smaller pieces. And so, for example, when I create an EKS cluster, I create the cluster, then I create things that go inside the cluster in a different state file, and then I orchestrate my Terraform to run first on cluster creation, then cluster provisioning as two different layers that depend on each other. And then I actually use CUE in my build system to say this layer depends on this other layer, and so run it after. But yeah.
Great. And how are you doing that? Are you using CUE command or tools flow to do that?
No. So I have a Go script that builds the diagram by reading the CUE config, and so I build a tree that then actually goes and executes Terraform directly, because I want to be able to not depend on my tooling. So I could still run Terraform without my tooling if I wanted to, but it's there.
It might be very interesting to, if you're aware of the tools flow package, if you're not, to take a look at that, because in terms of the declarations of such dependencies, doesn't matter how and where you declare them. The tools flow package exists in very large part to then take such a dependency graph and then do things with it and you define as the caller what you want to be done in those situations. So you could then just give ToolsFlow your dependency graph. Doesn't matter what the graph looks like, you can define that shape to it. And then you can also define what it should do when, if you like, a node within that graph is ready to be run. And it's only ready to be run when all of its dependencies have been satisfied. And then ToolsFlow then becomes a key part of your execution engine at that point there. But you don't need to worry about any of the dependencies. The ToolsFlow system also allows for you to, when a dependency completes, to add to the configuration graph so that the things that depend on it can then pull values. So you can push values through the system as well. It would be interesting to see whether that would help in your situation, because it sounds like it, as Jonathan said, we haven't had to do it here, but the ToolsFlow thing is an area which fits very squarely, I think, into what it is you were talking about there. So we'd be happy to follow up on that afterwards.
Awesome. I would love to see a presentation like this on that ToolsFlow as well.
Okay. All right. Well, there we go. There's. I will take a note, mental note, for us to do such a session.
Did Tiago? Did I catch that you hadn't got? You accidentally hit something, Tiago, or did you have a?
No, actually, I do have a question now.
Oh, great! Back with a real question. Fantastic.
Yeah. So in this example, and I've used CUE Uniform before. Just I'm started to use it, and in my example, I also don't have a dev and a staging environment. And for GitHub, like, you cannot have the same, right? You don't have a dev environment for an organization, for a project creation or anything of that. So basically, what I do to have a new environment, I just change. For example, if I'm working on AWS, I have a different account and a different state file, and possibly a different credentials. Just this change is enough to make me to have a identical environment managed by Terraform. Are you envisioning like CUE Uniform to be able to clone an environment, or like how I'm going to deploy the dev environment and then promote this change to stage and then production?
So the system that we're talking about today very much didn't have to address the concept of promotability, cross-environmental promotability, for exactly the reason that you say, which is, unless we wanted to have a completely parallel set of, smaller set of orgs, then there wasn't much point in doing that, coupled with how would you actually test that, the end-to-end testing of that in the context we were working in would have been painful. So that was just not an objective within this system. I think that in terms of the Cuneiform side of things, the project that I kicked off, that's something which we've yet to work out the ways of doing, the best practices for doing that in that world. Definitely worth a conversation outside the context of this chat, though. So yes, hit me up about that.
Thank you.
George, I think we had you next.
Yes, I want to comment about like what David mentioned. We actually tried doing that. So we tried generating Terraform for different layers, or a cluster layer, then configuring the Kubernetes cluster, and then adding resources. And you have to apply this like in order. We tried using the flow package, but we hit some issues because some of the internals that we wanted to leverage, like inside a custom Go program, we were not able to access it because they were internal package, internal packages within the Go repo, and they're not exposed yet. So we tried using Kubeflow to do that. We also tried the Go task. So like there's some makefile alternative where like the makefile is in YAML. So we're able to generate the YAML file that would like create a DAG of orders of applying Terraform in different order and creating different modules in different files to separate the states. So now you can generate with CUE the workflow that applies the Terraform code and the Terraform code itself. And this actually worked well in production. We're using it now.
Interesting.
That's fab. George, if there's a particular issue with the ToolsFlow internals or the internals, excuse me, that you felt you needed to get access via tools flow, if you don't mind highlighting that to me, then happy to take a look at that. There are some internals that are used by tools flow that we do want to promote to be exported packages, public packages. That's the reason they're not exposed yet, is we don't really know what the API should look like. That's absolutely not to say you can't use them. All you'll have to do for now is do a bit of copy paste. And as gross as that is, it's actually a very good way. So you sort of vendor it yourself, just change the import paths and you're off, because they have very light dependencies themselves, just depending on the CUE package, or they should only depend on the CUE package in most situations. So for folks running into those issues, please flag them so we can sort of help socialize what the problems might be with either tools flow, or actually, no, we need to make public this particular package here. Yeah, if you do want to kick the tires on those APIs or the internal packages, please do. It's a perfectly legitimate way to explore that. Roger
Yes,
might...
I tried copy pasting, but like I always found something that I don't have access to just to do this.
I think so. Certainly happy to explore that as well, because I think I have done it, and there is actually a good package that exists in the Go tools repository that helps with vendoring packages in this way, where they depend on other packages. So you can carry with all the dependencies that are themselves internal. And I think I have actually done that with but I might be mistaking it for another package. So let me prove that by actually doing it rather than waving my hands here. But George, thanks for the feedback. That's super interesting on the fact that you've had some success with this. It feels like it should be possible to do with tools flow. So it would be very interesting to see where you've run up against problems there. Tools flow is itself absolutely not perfect. It's like CUE command, the tooling layer. We're sort of learning a lot. Okay. Rog has then provided me with the detail there on the why we can't do that with that one. It must have been another package that I then did as part of the CUE playground. So yeah, we definitely do want to improve tools flow. So the things that people want to be able to do that they can't at the moment, it would be great to. We've got an issue that I will just try and dig out and share that folks can add points to as well.
I saw a question from Rog about 20 minutes ago, mid demo, asking if the queue that we were seeing was mapping directly to the JSON expected by Terraform. And whilst it generally does, it was kind of an explicit design goal of what we were doing to not build heavy abstractions over the top, only to build light abstractions where it made sense to do so. So yes, there's a bunch of you probably noticed in what we're doing, everything has a GitHub _ prefix. Yeah, we could do things like removing that because we're only talking about that and rehydrating that. We've actually built into the process as it were, a shadow copy of the information that's emitted, because in CUE we get to have identifiers that have much more freedom, which in the JSON that Terraform expects, we need to mutate that into a smaller set of characters so that we have valid Terraform identifiers. So we actually have a process within this which mutates the structure that you saw and turns it into something that is applicable, compatible with Terraform, and we could build more into that. We could have things sitting in the abstraction side on as you saw with the non-org member access, or we could put abstractions on the other side of the fence after the identifier mutation, or whilst the identifier mutation is going on. So as you see it at the moment, it's deliberately not highly abstracted, but there's definitely potential to do that if abstractions present themselves that are the right thing to do for lots of different people.
Rog, do you want to talk about that point anymore? Because I think it gets to sort of a fairly interesting decision that folks have when they're creating such systems.
Yeah, I mean, I'm just interested because when you talked about like, oh, this bit's an abstraction, from my point of view as a total Terraform naive person, I wasn't easily able to see what was an abstraction about that as opposed to any of the other bits. So
I thought you were actually going to get to sort of a wider point where particularly on the Kubernetes side of things, but certainly not limited to that, wherever Q is used, there always comes this question as to whether you should create an abstraction for an underlying system or not. And Kubernetes is a very good example because it's an incredibly large surface area of configuration. And there's a tendency, maybe tendency is the wrong word, a natural inclination might be a better phrase, to create an abstraction that presents a simpler interface to that thing that you're configuring.
And by abstraction, you kind of mean, like, as I understand it, a kind of transformation from parameters,
Exactly so.
Which is what your sort of inputs into some output.
Yes,
thing,
exactly.
right?
So yeah.
Yes.
And so this is a very, very well explored area that if only Marcel were here, he would be able to talk about at length. Folks from the Helm world will understand this problem in detail, because wherever you create an abstraction, over time, the abstraction breaks down because you end up basically providing an API to all the things that you're abstracting over. So the surface area of the abstraction isn't actually smaller over time. It is initially. You just work out that, oh, actually our abstraction is now broken down and we need to add this parameter here or that parameter there. So I thought that's where you were going with it, Rog. But anyway, great point to have brought up, because I think you actually bring up another point is where you're not creating abstractions by default, as we didn't in this situation, because we just wanted to keep it super raw and only create abstractions. Jonathan didn't quite say this, but where we were forced to. So in some situations, it's just not convenient to maintain a data structure in the form that Terraform wants and do anything useful with that in Q. A classic example being where we would ideally use associative lists, which we don't have yet. If we did have associative lists, we wouldn't need to create an abstraction. So for now, we've just tried to keep it super raw, not try and abstract anything, learn as best we can from what it is that's there. It's very raw. Step back from it sometime later and go, actually, would an abstraction be better in this situation? Because Terraform's structure is the JSON form of it is not really designed to be, well, it feels like it's not really designed for humans. It feels like it is designed for more a computer to actually chuck out something from some other data source. And so it always feels like we're slightly wrangling with it. And so maybe an abstraction in this situation, dare I say, an abstraction that more closely follows the actual things we're configuring on GitHub might actually be more appropriate in this situation, and then transform that into the format, because guess what? That's the form that we as humans are naturally going to be thinking of. Organization contains repositories. Repositories have these config values, etc. That feels like it is a more natural approach than basically what Terraform has. It's like a flat, long list of resources that you need to create. So that in and of itself is like a transformed version of reality in the first place.
And that was a very conscious decision early in this process, that we weren't going to provide that top-down, single, holistic view of it that we then try to, because we didn't want to bake in an abstraction early. It might be the sort of thing that we'd now refactor out and go, this makes sense to have that. And that may be a next step that the CUE project, indeed folks who maybe want to contribute with issues or code into this, say, yeah, it makes sense to do that in this context.
But from my understanding, when you're talking about doing those kinds of abstractions and transformation, this is all happening within one logical configuration tree, right? So you're basically mapping one part of the configuration tree to another, but you're not kind of excluding, by that version of that transformation, you're not excluding the possibility of changing the other path as well, right? If that's a more appropriate place to change, or placing constraints of the other path, or anything like that, which is, I think, is one of the sort of main insights of how CUE can operate and operates best.
Completely, yeah. David, I think you or somebody had a hand up, and apologies, we missed that.
No, no worries. This is a very interesting conversation for sure. My question was a bit off topic. You guys have had some sessions in regards to Pulumi before and the integration with CUE. And I just wanted to know if you explored any Pulumi workflows for managing GitHub Actions or what the status there is, because it might be a little more native in that regard.
So in the context of the system that we developed, as I mentioned earlier on in the presentation, there are various options around doing things in this space that is managing more in the programming language side of things, more in the different abstractions, different forms of structured data. We dropped in with Terraform relatively early because it felt like the right thing to do for the experiment of getting what's the experience of doing this like. I can't speak as for anything else in the Pulumi sense, so perhaps Paul, is there anything you have in that context?
No, it's a good question. I would only end up repeating what Jonathan said. Certainly happy to explore. David, you were talking about GitHub Actions in particular. What we do as far as GitHub Actions concerned is actually very, very lightweight. In that all we do is represent the workflows and jobs within those workflows in CUE and spit them out as YAML. We then use essentially CUE primitives like templating, let declarations to dry things up, to then just make it a much more type-safe and natural way of declaring those workflows. We also then have things like reuse between repositories. And if you squint hard enough at what we've been doing here, we have a central configuration infrastructure repository where we're declaring our organization and repository structure. In my head, if I think about GitHub Actions or CI in general within a repository, it's a combination of two things. It's a combination of the code, the configuration within that repository itself, plus there's some policy that should really come down from above when it comes to defining what should happen in CI and repositories. So our central infrastructure repository, it should, to my mind, be in some part influencing, particularly from a policy perspective, what workflows in repositories are doing. It can't do it completely, so you can't push everything down from above. As in, it needs to be some combination, and I think BuildKite actually does this quite well in having the concept of dynamic workflows, where you have effectively, as CUE does very well, different aspects to a workflow specification, where you say, well, I'll define this aspect over here, this aspect over here. And if you consider things like secrets being another aspect, well, they're in some other system almost by definition. And then the concept of dynamic workflows, as I understand it with BuildKite, is it delays until the last minute the computation of the actual workflow that runs. And so it pulls all those bits together. And CUE would be a very good fit in that situation for that system, because you can express all the aspects by themselves, and you can vet them and validate them ahead of time before you combine them. You can describe the composition of them in a principled way as well, in a type-safe way. And then the engine that effectively combines them, if you wanted to consider it that, at the point of combining all of those workflows just before they're executed, could also be CUE at that point, or something similar to it that does all the type checking, validation, and then spits out whatever configuration language is required by the system. Because that's something that we didn't actually talk about here, is that, of course, in this, GitHub has not had to understand anything about CUE in any way, shape, or form, either from a configuration in the organization or repository perspective, or the workflow perspective. The fact that we're managing it with CUE, they have no idea about, and that's a good thing. So from like an adoption perspective, that's a nice thing. It's a very low risk thing. You can also do something in parallel before having to flip over as well.
In regards to the schema for the Terraform JSON, is that published, or is that something you had to a bit reverse engineer? Were you able to pull it in any way?
So that's something very near and dear to my
Good question.
Heart, which is, there isn't a properly published one for the Terraform top level config that Terraform expects, we have gone through documentation and created that. There is not, there is from on a provider basis, there is a mechanism to get hold of a version of the schema that the provider expects for each of its resources and data types. And I think indeed it's the provider configuration. Turning that into something that's assertable in CUE, that is currently the focus of what Cuneiform is doing. I'm trying to get to a place where that is a consumable artifact, whether it be in projects like this, whether it be in using Cuneiform's more opinions baked on top of it, be it someone who just wants to go, I'm just going to do my own CUE and I want something to build on. So getting to the place where that's in an available artifact, it's doable. It's just turning out to be quite painful to do. But in terms of the top level Terraform one, inside Cuneiform, as well as here, there is a definition of what certainly I think Terraform 1.4 expects. I'm not going to argue that it's definitely 100% correct because it's generated from code that's coming in. That's not it. This has been hand cranked from reading through documentation and taking certain opinions about the JSON form, such as, for instance, whether or not you have structs or where you have lists of struct. Both of those are valid, which makes things really annoying to deal with. So you can steal the one from in here. You can steal the one that's sitting around in Cuneiform. If you've got a better one, please point to it, and I can come and steal that and use it in any other place where I'm using it. So yeah, that's definitely an interesting wrinkle, is Terraform's lack of introspection into what it is, or reflection perhaps into what it is that we can throw at it.
I don't want to take too much time, but that's what drove me away from HCL as a language, is the fact that HCL is HCL base, and then Terraform is a different HCL altogether with different abstractions and functions and stuff like that, that it's added to the base language. And then when you use the HCL Go code, you cannot, in many cases, even work with the Terraform as abstractions to parsing and stuff. So it drove me away, and then I found CUE, and CUE has been that language that allows me to use the standard library in the configuration right there, and then configure tools and scripts. Yeah.
The purpose of Cuneiform when I kicked it off was to say, why should we just be describing exactly what anyone can do in any form inside HCL's JSON form, or should we just try and actually put some more opinions on this? And I think that that's worth doing, so that everyone doesn't have to reinvent the wheel. Every single time you come to, can we emit something from CUE into Terraform to drive Terraform? It would be nice if there were some batteries to get you started with, as opposed to everyone having to start at that very, very low layer of, well, squint a bit and look at a schema. So I urge you to have a look at that, look at this project, and have a look at Cuneiform and see if there's stuff that you can use, or indeed stuff of yours that we could use in either of these.
I think we should just keep an eye on the time and give it a couple more minutes. But David, just to also flag that whenever we're talking about schemas, sharing schemas between things, that brings us to the area of modules. And modules will be the means by which, when somebody has a schema they want to share and publish, they publish it as part of a module, and that would then be natively CUE gettable via the CUE tooling and usable within other code. Let's have a quick look. Tiago says, now I have another reason to not use Pulumi. How can we contribute Terraform resource schema? We have a lot. Sounds like conversations there offline. We better wrap up now, just in the interest of time. But George, Jonathan, I think there's sort of an interesting space there to explore in terms of how to collaborate in this space. Please feel free to use the CUE repo for that, or if actually you think it belongs better in the Cuneiform repository there as well. To what extent that there's different experiments that go on within the CUE community. I think Jonathan would sort of accept as well that his is an experiment in this space as well, and it's more like a million flowers should bloom in this space, and work out what is actually the best
100%.
in that respect. So
100%.
as the CUE project, we're not saying, oh, we're blessing one versus the other. We're there. So if folks are running into problems in their approach, please just let us know, right? That we have no favor for one thing or the other. We're just there to try and help unblock on the CUE side of things as best as possible.
Hit me up on the CUE Slack, George.
Great. I think we've actually been recording for almost exactly an hour. So I'll use this opportunity to say thank you very much to Jonathan, first of all, who's been working with us for the last few months on this. Thanks to everybody for joining. Thoroughly great session today. Some wonderful questions. Hopefully this is the, Cedric's waving, lots of waves and things. Fantastic. We'll put up the recording on YouTube. We already have the GitHub discussion if folks want to ask any further questions in there. Otherwise, there's always the CUE Slack. And I forget who it was, David, it was the Tools Flow working session. I think I've taken down a note on that. We'll absolutely do something live on that, because that's actually quite a fun thing to do a session on as well, I think.
Thank you.
Thanks, everybody, and look forward to catching up on another session in the future.
Cheers, folks. Catch you soon.
Thank you.
Thanks.
Thank you.